Hey everyone, welcome back to the channel. This is Rahul. Today we are diving deep into one of the most common and elegant problems in coding interviews, that is the next permutation. Whether you are preparing for a coding contest, a technical interview, or simply sharpening your algorithmic skills, this video has you covered. So grab your notebook and let's get started. So the problem is simple yet fascinating. Given an array representing a permutation of numbers, we need to rearrange the number into the lexicographically next greater permutation. If such a permutation doesn't exist, we return the smallest permutation, which is just the array sorted in ascending order. Let me show you one example. So here you can see 241750. The next permutation will be 245017. But if the input is already the largest permutation, like I'll just show you here, like 7 4 sorry 2, okay, largest permutation like 7 5 4 2 1 0, then the largest permutation will be like the output will wrap around and become the smallest permutation, that will be like 0 1 2 4 5 7. So that's the thing. So in this way we have to write this code. We will walk through the code while explaining each part. So it have actually three sections. First one, find the pivot. Second, find the successor. Third, revise the suffix. So let's get into the coding session. First of all, we need to find the pivot, which is the first element from the right that is smaller than its next one. So this pivot helps us identify where the rearrangement should begin. So we will start from the second last element. For that, I am initializing one variable I, array dot length minus 2. So and we are moving backward until we find an element array of I that's smaller than the next one. If no such element exists, it means the array is in descending order and we need to return the smallest permutation. While I greater than equal to 0 and array of I greater than equal to array of I plus 1, then decrement I. So we done our first step. Here what's happen is when we take this example 2 for 1750. So starting from the right we check 5 greater than 0, 7 greater than 5, 1 less than 7. And the pivot is 1 at index 2. Like that it will start. Next step is find the successor. So if a pivot is found, the next step is to find the successor, which is the smallest element in the suffix that's larger than the pivot. Then we swap these two elements. So let's start with that. If I greater than equal to 0, j equal to dot length minus 1 while array of j less than equal to array of I. Then we have to decrement j. So now we have to swap these array of I and array of j. So for that we will use one temporary variable. I will use temp array of I, array of I equal to array of j, then array of j equal to temp. So when we come here in this example, the pivot is 1. We already mentioned that. Now we scan the right side of the array to find the smallest element larger than 1. That is 5. Then we swap 1 and 5. So the array becomes 2, 4, 5, 7, 1, 0. Okay. So we are getting into the last step, that's to reverse the suffix. So this ensures the suffix is in ascending order, giving us the smallest possible arrangement. So I am using the inbuilt method rs.sort array I plus 1 array.length. So when we get into the example part, uh, the suffix after index is 2. Index 2 is 710. So sorting it gives 017. So the final array becomes 2, 4, 5, 0, 1, 7, which is the next permutation. So let's run it. Yeah, it's working. Let's submit. Yeah, it's efficient. So this code is clean, concise, and interview ready. When it comes to complexity, it becomes big of n log n due to sorting and uses big of 1 space complexity as it modifies the array in place. So I hope you understand with the example that I mentioned, and that's how you solve the next permutation problem. If you found this explanation helpful, don't forget to hit the like button, subscribe, and turn on notifications so you don't miss out on future videos. Got questions or other topics you would like me to cover? Drop them in comments below. Thanks for watching and happy coding.